For decades, the iron law of global manufacturing was simple and absolute. Capital always flows wherever labor is cheapest. That relentless search for low hourly wages, combined with massive infrastructure and deep supply chains, built China into the undisputed center of global production. But economies mature. As Chinese wages climbed, multinational corporations began looking for the exit, redistributing their supply chains into newer, lower-cost regions to protect their profit margins. Right now, Vietnam is one of the clearest examples of this shift. Massive investments from companies like Samsung show a real-time relocation of global industry. There is a flaw in treating any country as a permanent low-cost haven, though. Rapid industrial growth increases demand for skilled workers, and that competition inevitably drives local wages up. To see where this cycle ultimately leads, we have to look back at how China is handling its own rising labor costs. This chart shows the density of industrial robots in Chinese manufacturing. Look at the recent spike. According to the International Federation of Robotics, by 2024, China reached 567 industrial robots for every 10,000 employees. The total value of repetitive manual labor is shrinking globally. So how can a high-wage region in Europe ever compete in an industrial landscape where low wages no longer decide who wins? The answer requires a different way to measure competitiveness. Success is now driven by system-wide capability. That means how much value you extract per worker, how efficiently you manage energy, and how continuously your technology improves. The Waste Magic Calabria project is engineered exactly for this new metric. It serves as a blueprint for high-value European manufacturing. Instead of building an isolated factory, the project creates an integrated industrial campus. By applying smart automation to the most hazardous and highly standardized tasks, the core technology scales up reliably and safely. Humans are still critical to this environment. Their roles simply shift away from manual repetition and move directly into advanced engineering, process optimization, and systems control. To sustain those advanced roles, the campus integrates a technical academy right on site, making it one of the project's most strategic assets. Co-locating research and development with active production radically shortens the improvement cycle. Local talent moves from the academy into R&D, and their discoveries are directly tested and applied on the factory floor. Alongside human capital, the physical infrastructure of the campus is engineered to withstand external shocks. European energy markets can be volatile. To mitigate that risk, the site architecture incorporates solar generation, heavy battery storage, and advanced heat recovery systems. The goal isn't to disconnect from the grid completely. It's to reduce unnecessary external dependencies, which lowers operating risk and guarantees commercial predictability. When you merge a dedicated talent pipeline with self-optimizing energy systems, the campus actually improves its own economics year after year. It bypasses the vulnerabilities of the old cheap labor manufacturing model. For regional governments and stakeholders, this changes how public investment should be evaluated. Public support for this site acts as seed capital to establish a globally competitive industrial platform. It is not a permanent subsidy designed to prop up conventional factory jobs. The returns on this investment are durable. The region retains deep technical knowledge, creates a pipeline of advanced skills, and builds highly efficient circular infrastructure. Investing in this kind of systemic engineering creates an advantage that outlasts the temporary fleeting margins of low hourly wages. As the global manufacturing center of gravity shifts toward automation, the Waste Magic Calabria campus is perfectly positioned to compete. Not because labor is cheaper, but because the entire system is designed better.